In this recording, we're going to look at the Investigate the Math probability question on page 354 of the textbook. It's about independent and dependent probabilities. So we're given two situations. Anne and Abby both have 19 marbles, 11 red and 8 blue. And Anne takes her marbles and splits them into two bags. She puts 7 red and 3 blue in the first one, and 4 red and 5 blue in the second. Whereas Abby puts all of hers in the same bag. So she has 11 red and 8 blue in one bag. And then we're asked a series of questions related to this scenario, this situation. So the first question, A, says let A represent Anne drawing a marble from bag 1 and B, Anne drawing a marble from bag 2. Are A and B independent? So A is red from bag 1 and B is red from bag 2. And are these events independent? And the answer to that question is yes. The two events are independent because the chance of getting a red marble from the second bag is not affected by the red marble in the first bag. When two events are truly independent, the probability of one does not affect the probability of another. So the chance of getting a red marble out of the second bag isn't going to change regardless of what happens when she takes a marble from the first bag. So those two events are independent of one another. Then question B says, let C represent a red marble from bag 3 and D a second red marble. So what happens is a red marble comes out and then she draws another one and gets a second red marble. So she's drawing two red marbles out of the same bag. So the question then asks, are C and D dependent or independent? C and D are dependent upon one another because the first one event changes the probability of the second event. So since one event changes the probability of the other, they're dependent upon each other. Because once one red marble comes out, then there's no longer 19 marbles in the bag, there's only 18. And there's no longer 11 red marbles, there's only 10. So two events are dependent upon one another if one changes the probability of another. So question C says determine the probability of A and then the probability of B. So the probability of A, well, in the first bag, there are 7 red marbles out of 10 altogether. So the probability of A is 7 in 10. Probability of B In the second bag, there are 4 red marbles and 9 altogether. So the probability of B is going to be 4 and 9. Then question D says, what's the probability of A and B? So because the two events are independent of one another, we know when events are mutually exclusive or independent, find the probability. The chance of getting in the first one is 7 and 10, and the second one is 4 and 9. So what we get is 7 times 4 is 28 over 90. Now the question asked us to solve this to 3 decimal places. So when we calculate 40 over 90, 28 divided by 90 gives us 0.311. So the probability of getting a red marble in the first bag and a red marble in the second bag is 0.311. Question E says, what's the probability of C? The probability of C is going to be equal to C is drawing a red marble from bag 3. So there's 11 red marbles and 19 marbles altogether. The probability of C is going to be 11 over 19. Then question E also says, what is the probability of D given that C occurs? So you have to think about this one as a conditional probability. So recall from the last section that the probability of D given C is equal to the probability of D in union with C all over the probability of D. So if we think about that, probability of D given C all over the probability of D. Once that marble comes out, once that event has happened, given the marble is drawn on the first one, then the second one, there's only going to be, after that first red marble is removed, this number here is not going to change. It's not going to stay at 11. It's going to be decreased down to 10. We're going to have 10 marbles and a total of 18 left. So on the second draw, the chance of getting it is going to be 10 and 18. Because there's 10 red marbles left and there's only 18 marbles left altogether. So we have the probability of C and the probability of D. So then it says determine the probability of C and D. So what is the probability of C and D? Well, the probability of C is 11 and 19. Probability of D is 10 and 18. So if we calculate that to 3 decimal places, we get 110 divided by 342, and that gives us a probability of 0.322. have a probability of 0.322 of Abby getting 2 red marbles. Now the girls equally likely to draw, question G says, are the girls equally likely to draw 2 red marbles? And the answer is no. Abby has a slightly greater chance. (32.2%) than Anne, who has a 31.1% of drawing 2 red marbles. So Abby has a slightly greater chance, not a lot greater, just 1% probability greater, but she does have a slightly greater chance of getting the 2. So then there's a couple other questions related to this. Question H says, explain how you can tell if 2 events are independent or dependent. And the simplest way to answer that question is to say 2 events are independent if the probability of one does not affect the probability of another. So the probability of getting a red from bag 1 for Anne didn't affect the probability of getting a red from bag 2. But for Abby, they were dependent upon one another because once that first red marble was drawn, the probability decreased. The chance of her getting a red marble on the second one had changed because there were fewer red marbles and fewer marbles altogether in the bag. Question I says, suppose if Abby were to draw her marbles together instead of drawing one after another. Would this affect the probability of Abby drawing 2 red marbles? And technically, no, it would not, because she still, even if you pull them out simultaneously, it's still the same as grabbing one at a time. Probability is going to be the same of getting 1 red and 2 red when she takes them both at the exact same time, because she still has to select or pick 2 marbles from the bag. So she's picking 2 at once, which is the same as picking one, then picking the other. Now, one thing that you can look at, though, is Abby's probability could have been made independent if she had replaced the red marble after she took the first one out. She took the first one out and then put it back in, then the probability would become independent because the probability of one would not affect the probability of the other. So question J says, Naveen used the following formula to determine the probability of Anne drawing 2 red marbles. The probability of A and B is the probability of A times the probability of A given B. It says, would this formula work for Anne? And no, this formula would not work for Anne because the probability of B has nothing to do with the probability of A. So B is completely independent of A. So the probability of A and B for any independent event, the probability of A and B is equal to the probability of A times the probability of B for any case, as long as the 2 events are independent of each other.